So here we have this new specification, this diagram. And it turns out there's a fairly systematic way to convert this diagram. Now that you've thought about this, it's easy to design, I think, state machines using this sort of arc and circled, circles for the state, arcs for the transitions. You can sort of understand what's happening at this level. And now I'm going to translate it into a truth table by keeping track of what the current state is and the current input, and then indicate what the next state is and what the unlock bit is. So what I've done is each of these rows here corresponds to for every arc in this diagram there is a row in this truth table. And what I've done is I've said the current state is where the arc is coming from, the next state is where the arc is going to, and then this unlock line is really just a function of the current state. It doesn't depend on the input. But I can put it all in the same truth table. You say, well, this is great, Chris. The trouble, of course, is that that's a symbolic name for a state. So instead, what I'm going to have to do is come up with a numeric encoding for my state names to turn this into an actual diagram, an actual truth table, from which I can now, how to design combinational logic using a read-only memory, or using a sum of products implementation, or any Carnot maps, any one of a number of ways. This is arbitrary. But it turns out that if you're careful about how you do this data assignment, sometimes your logic is a lot less. Because some of these truth tables turn out to be, trivially implemented, and others require lots and lots of gates. Right? And so if you're actually pretty good at the state assignments, you can usually make your logic, the actual logic you have to build to implement the state machine, smaller. Okay. So are we all happy here? State diagram. We'll go through some more diagrams of building a state machine in a moment. That'll be fun. But meanwhile, just the mechanics of it, we have this diagram. We have a way of turning this into a truth table. And now we're really pretty much all set to actually design the circuit that implements this finite state machine. The FSM is really just our abstract way of thinking about what we wanted the state machine to do.